Good afternoon, Dr. Zhang. So today I'm going to demonstrate the force of buoyancy. And before starting the experiment, I would like to explain what the buoyant force or upthrust means. So it is an upward force which is exerted by the fluid on the partially or fully submerged object. So the buoyancy force is equal to the weight of the liquid displaced by that object. So for this experiment, I have two objects. I have orange and I have egg, and I have two glasses. One glasses I have clear water, and one glasses I have add a little bit of salt, and I'm gonna add more if I need to. So for the experiment, what I am going to do is I'm going to test the force of buoyancy for the egg first. So first of all, what I'm gonna do is I'm gonna see if the egg floats in clear water or does it sink. So let's see. So if I put it over here, as you can see, it sinks completely at the bottom. Now it displaces some liquid up, which we don't need it for this experiment. And let's see what happens if you put it on the salt, float or sink. As you can see, this thing is floating, and I'm gonna explain about this on the theoretical part. And for the second part, I have an orange. So let's see what happens if I put orange on a clear water. It is gonna float. So let's see what happens if I peel this orange off and then do the same process again. Okay, so let's see. As you can see, this thing completely sinks in water. So this is the phenomena of buoyancy, which I'm gonna explain on my paperwork. So as you can see, I have the first condition, one with the salt water and one with the clear water. So for the salt water, it's gonna sink because the force of buoyancy is less than the gravity. And for the second one, when the salt is added, as you can see, the density of the liquid increases, which is directly proportional to the force of buoyancy. That's why the force of buoyancy increases, which uplifts the egg and makes it float in water. For the second case with the orange, what happens is density of the orange. We are taking density of the orange because the density of the fluid is same in both cases, and the density is mass times volume, as you can know, but the volume is directly proportional to area, so we are changing the area by peeling it off. So for the unpeeled orange, it's gonna float in water because the area is greater and density is less. But for the peeled one, the area will be less and density will be more, and it's gonna sink down to the bottom. Also, there are no air space in the peeled orange, whereas there's air space in between the orange and the outer layer. That's why it floats. So same application is applied by the big ships. As you can see, the big ships floats in water, whereas a small needle, they sink in water. It's because of the force of buoyancy. That's the law of buoyancy, because if the object displaces the amount of liquid equals to its weight, it can float in water. Wherever if it doesn't displace the same amount of liquid, it's gonna sink.